Much of today's fabrication is automated with computerized numerical control, or CNC, where machine tools, including punch presses, mills, and lasers, are operated by precisely programmed commands entered into a computer. But what are the differences between these three processes? And how do you determine which process is best for your particular part, whether they are data plates for tractor trailers or front panels for modular synthesizers? Let's have a look. Punching uses hydraulic, pneumatic, or electrical power to press a shape, where a punch is forced through metal, consequently shearing the metal. During the process, the punch often passes through the metal into a die, creating a scrap slug. Depending on the material being punched, this slug may be recycled and reused or discarded. When a specially shaped punch is used to create multiple usable parts from a sheet of material, the process is known as blanking. Punching is quick and the most cost-effective process of making holes of varying shapes and sizes in strip or sheet metal for medium to high production volumes. However, if existing punches do not fit or meet job requirements, custom tooling is required, which can be costly. Punched parts will have one or more distinctive characteristics, including rollover, burnishing, fractures, and burrs. As the punch engages the sheet metal, it pulls the material downward, slightly drawing the material into the clearance, which creates rollover. As the punch continues to penetrate and shear the upper portion of the material becomes locked between the punch and the die, which creates a burnished area before the remaining material fractures and separates completely. As the punch makes its exit through the material, it again forces the material downward, leaving a small piece of material remaining attached to the workpiece. This is called a burr. These are important considerations for jobs with high finish specifications because these types of blemishes require additional finishing processes, which will increase time to finish and costs. Milling is a process that removes material by performing many separate small cuts with the use of milling cutters, which have numerous cutting edges, called flutes or teeth. A milling cutter spins at very high speeds, repeatedly cutting into and exiting from the material. The blades of the cutter take swarfs of material at regular intervals, creating a distinctive characteristic in the finish. A surface cut by the side of the cutter will contain revolution ridges, while face milling will produce trochoidal or revolution marks. Revolution marks are typically very smooth, and precise milling operations are capable of producing revolution marks that are only microscopic scratches due to imperfections in the cutting edge. An advantage of milling is that it is capable of much lower tolerances than punching. However, if existing milling cutters do not meet your job requirements, you will have to invest in custom tooling. Laser cutting uses optics to direct the output of a high-power laser at the material, which then either melts, burns, vaporizes away, or is blown away by a jet of gas. Because lasers do not use any type of tooling, there is no direct contact between the laser device and the material, reducing the chance of contamination or accidental marking. And because lasers create a smaller heat-affected zone, the risk of material warping and deformation at the cutting site is also reduced. Laser cutting leaves clean edges with a high-quality surface finish, making it a seemingly more streamlined process than mechanical alternatives, which often require post-machining treatments. Like milling, lasers are known for precision and accuracy, with some capable of tolerances within 1/1000th of an inch or 25/1000ths of a millimeter. This degree of precision makes laser cutting more costly than punching. As you can see, each of these methods employs distinct equipment that may create distinctive characteristics on finished parts. This chart provides a general comparison of these fabrication methods as they relate to cost, output, accuracy, and quality. Variables such as substrate, material thickness, tolerances, quantity, and lead time help determine which will be the most cost-effective method while delivering the accuracy and quality you require. Work with a trusted source and weigh the benefits of one method of fabrication versus the cost and risk of damaging or deforming a given material. It is also worthwhile to know that these processes need not be exclusive of one another. You may find that the best process for your part is not just one, but a combination. Metalphoto of Cincinnati evaluates each job to determine the best manufacturing process, taking into consideration the thickness of the material and your finish and price requirements to provide you with quality parts. It's just one reason that makes us a leading manufacturer of custom data plates and front panels. Contact MPC about your project